Hello, welcome to numbers 1, fractions, decimals, and percentages. So, what is a fraction? A fraction is just a part of a whole. So, hold on, let me just finish writing this. A fraction is a part of a whole. So, if I have one pizza, let's take this pizza, and usually these are cut into slices of 8. But yeah, so if I have one pizza, I could say that I have one whole pizza. And if I take one of these slices, so let's take this slice of pizza, and since there's 8 slices, I could say that I have 1/8 of the pizza. So what we gotta remember is that a fraction is a part of a whole. Now this whole could be literally anything. It could be pizza, it could be a donut, it could be a cat, it could be whatever you want. Now, let's get into some terminology. So let's take this 1/8 fraction. So let's draw this a bit bigger. 1/8. So these two numbers, this guy over here and this guy over here, they actually have different names. So let's start with the bottom one over here. So this is called the denominator. And what this tells us is how many slices or how many pieces we need to make a whole. So how many pieces do we need to make a whole pizza? Well, we would probably need 8 pizzas unless you shop at Costco where they have pizzas sliced into 6 pieces. But most likely you're going to have a pizza sliced into 8. So we would need 8 slices to make a whole pizza. And if it was like something like a cake that was sliced into 4 pieces because you've got 3 friends and you want to eat some cake as well, then this denominator would be the number 4 and not 8. So this just represents it represents how many pieces you need to make the whole. Let me write that down. Okay, and moving on, we've got the numerator. And what this does is it basically just tells us how many pieces we have. So this is how many we need to make a whole. And this top one is how many we have. If I do have this pizza and if I take 1/8 the pizza, but my friend Bob over here, he takes 5/8 of the pizza because he's just really, really hungry. And this can be me. Bob. And I have 1/8. We can see that the total number of pieces of that pizza remains the same. It doesn't change because why would it change? The pizza has not changed. We haven't cut more slices. We haven't added more slices or more material because it's legit. It's just the same. The only difference is I've taken 1 piece, whereas he has taken 5. We can represent fractions in 3 different ways. So the first one is the normal one, which we're usually pretty used to, which is called proper fractions. And these are your half or your 3/4 or your 1/8 like before. And the characteristic of all these, what they have is that a proper fraction is less than 1. So half, 3/4, and 1/8, these are all numbers that are less than 1. But what if we have a number that is more than 1, but it's not an integer like 1 or 2. It's not a whole number like that. So it could be something like I have 1.5 pizzas because my friend Bob, he ate half of the pizza that I bought. So I bought 2 of them and he just ate half of it without my permission. So now I only have 1.5 pieces. What we would use for this is called a mixed fraction. So this is something like 1.5. Now this notation, it's a little bit confusing. So don't worry too much about it. You're not going to use them a lot, but it is good to know how to convert from this into something called a improper fraction. And now you're going to see a lot of improper fractions. Basically, this is any number that is greater than 1, but isn't a whole number like 1, 2, and so on. Let's think about the mixed fraction. So how can we think about this visually? If I have 1.5 pizzas, then I've got 1 pizza, 2 pizza originally, and then Bob took this part of the pizza. He just ate it. So now I only have 1.5 of them. So when I'm writing in this notation, I firstly write the whole. So I've got 1 whole and I've got 1 half. So if I however many wholes I have of whatever thing I have, if it's donuts, doesn't matter. Right now we're talking about pizza. However many wholes I have, I write it in big right here. And however many fraction parts that I have, I write little next to it. So if I had 3 pizzas instead of 2, and Bob still had this half, but I have 2 pizzas and a half, then this guy over here, this guy would actually be 2, just like that. I would have two whole pizzas, 1, 2, and a half, plus 1/2. That's why we've got 2.5 here. It's not exactly confusing, but it is kind of bad notation. I don't really like it. So we have this thing called an improper fraction. So how can we represent 2.5 without using this weird notation? Well, we can actually represent this as 5/2. Now you might be asking me, how the heck did we get to 5/2 from 2.5? Well, let's think about it. When we're talking about mixed fractions, we are doing it in terms of the whole. So if I've got 1 pizza, 2 pizza, 3 pizzas, and they're all cut in half instead of 8s for some reason, maybe this was a special request pizza, and over here we've got 2.5, right? So we've got this whole pizza, we've got this whole pizza, that's 1, 2, and we've also got this half piece. So that's 2.5, correct? So how is this 5/2? That doesn't make any sense, does it? Well, 5/2 is actually the exact same thing as 5 times half. So we have to think about this in terms of half pizzas instead of thinking about them in whole pizzas. So when we look at it in terms of half pizzas, let's use a nice pink color. We've got 1 half here. We've got the second half here. Got the third half here. The fourth half here. And the fifth half right there. So we've got 5 halves. And when you multiply like this, you just multiply. I'll explain that a little bit better later on when we get to operations with fractions. But so far, this is basically all you need to know. So next up, we've got decimals, and they're really nothing too intimidating. The only difference between a fraction and a decimal is the difference is what we write them in respect to. So a fraction, it could have anything. Remember, we defined the denominator as being the amount of pieces we need to make the whole. It could literally be absolutely anything. We could have it being something like 99999 and so on for another 100 digits, and that could be our denominator if we really wanted it to, and we could have 1 over that. But the difference between that and a decimal is that a decimal basically puts it into perspective of the place value system. So if you are an English-speaking person or live in an English-speaking country, you're probably used to these digits. Oops. My handwriting. You're probably used to these ones. So these are actually called Arabic numerals. These are completely different from Roman numerals, which are, I'm sure you know, which is something like I, or like something like IV. But basically what a decimal does is it shows the fraction, but in terms of the place value system. So what is a place value system, you might be thinking? Well, let's think about it. So in terms of our numbers, we've got all these numbers here. And let's start with the 1 right here. Let's put 1 right here. This is 1. Okay. And I'm gonna actually draw a nice big line. So we've got ones, or 1 here. And if we times this by 10, we can get to 10. And if we times this by 10, we can get to 100. If we times this by 10, we get to 1000. And this will make sense in a second. But if we go backwards, we go the other direction, towards the right, and we divide by 10, we get a special little number, 0.1. Now this thing right here, let me get another color for you. I use pink. This thing right here, this is called a decimal. And what it signifies is that it's a fraction. It's less than 1. Everything on the other side of this is less than 1. So if I had something like 3.5, this is 3 wholes with a half next to it. That's not a very good explanation, is it? Okay, so we'll come back to that decimal point right there in a second. But if you divide that by 10 again, I've kind of blocked myself there. If I divide that by 10, we're gonna get 0.01. And if you divide that by 10 one more time, we're gonna get 0.001. Okay. Now, I'm gonna show you something very interesting. Remember our fractions? So if we had 1/8, for example, 1/8, sorry, what do we say? This is 1/8, correct? The th here. And if we had something like 1/9, we would say this is 1/9, no? So if we have something 1/10, what do we say? This is 1/10. And coincidentally, this place value, this column right here, this one right here, this is called the tenths. This one's called the ones. This one's the tens. This one's the hundreds. And this one's the thousands. And you can probably imagine what happens when we go this direction. Hundreds. Hundredths. Sorry. And this one's thousandths. There you go. So we can see how when we multiply by 10 or divide by 10, they get smaller in proportionally. Not in proportionally, I just stuttered. Sorry. Alright, so if we take a look at the number line, we can see that we got 0, 1, and 2, and this will continue onwards forever in infinity, and it will actually go the other way as well, but we don't have to worry about that for now. But what about the numbers in between 0 and 1? What about them, right? Well, let's say we want half of 1. It would lie somewhere around here, and that we could say that that is 1/2, correct? Let me write that a little nicer. 1/2. But if we use the decimal notation, which is it's quite literally just a different notation, but you just have to remember the rules behind it. It might be easier, might be harder for you. We can say that it is 0.5. Same with, let's say, 8/10, which could be rewritten as 4/5. This would be 0.8. Or perhaps you want to do 1/10. 1/10 down here. You could write this as 0.1. And so on. And there's an infinite number of fractions between 0 and 1, which could be represented as decimals. So basically what a decimal does is it takes a fraction and it compares it to 1. So like these 0 0.5, 0 0.1, what is this 1 in respect to? It's 1, well, we looked at the place value before, didn't we? So this 0 0.1, this is in the tenths. It is 1/10 of 1. This is quite literally, it's 1/10 of 1. So when we look at 0 0.1, it's not just a number. It's directly correspondent to this 1/10. Same with 0 0.5. It is 5/10 of 1. So this is 5/10 of the number 1. And that is the same thing as saying 5/10, which we can simplify to 1/2, which is the same as half. So they're directly correspondent. It's just a different notation. So it's really nothing to be worried about. Converting from them is pretty self-explanatory. I'm not going to go into too much detail on that. If you do need help, please leave a comment down below. I'll elaborate on that matter. So what are percentages? Well, we know what fractions and decimals are, so percentages should be nothing to us. Similar to how a decimal is a fraction compared to 1, a percentage is a fraction compared to 100. So let's use 3/10 as the example again, because it's a nice number. If we convert this to decimal, it's equal to 0.3. And I'm sure that makes sense now, because it's 3/10. This is 3 times 0.1, and remember this is called 1/10. So it's 3/10. Correct? That makes sense. But we can also say that this is 30%. How? How can we do that? So let's work through this. So how can we convert from a fraction or a decimal into a percentage? So let's take a fraction, 3/10, for example, and let's look at this. We're pretty used to simplifying fractions, so we could go from something like 2/4 to 1/2, but we're not used to going the other direction. What we can actually do is we can rewrite this 3/10 as a fraction over 100. How can we do this? So we multiplied the denominator by 10 to get to 100. 10 times 10 is 100. Then we can multiply the numerator by 10 as well. So you'd get 30 over 100. And remember, a percentage is a fraction with denominator equal to 100. So we've actually gotten our answer. This 30 over 100, we can just say that it's 30%. We don't need to say 30 over 100. I mean, who would say that in this day and age? We would just say 30% instead. It's that simple. All right, so let's look a little bit into operations. And we're mainly going to focus on fractions. So, if we have something like multiplying fractions, so let's say we have 1/2 times 1/2. What can we actually do? Well, with multiplication, a lot of people get a bit scared. It's actually much simpler than even addition, which most people think is pretty straightforward. With fractions, with multiplication, what you can do is just you multiply these guys and you multiply these guys. So we're going to end up with 1 times 1 is 1 over 2 times 2, which is 4. So half times half is equal to 1/4. Let's look at a bit of a harder one. So let's go with 8 over, let's go 9 times 3/4. Excuse me. So what can we do with this? Well, we just multiply 8 times 3, which is 24. And we put that over 9 times 4, which is 36. There we got our answer. And we can simplify this. So divide by 2, we got 12 over 18. And we can simplify this again. We can go to 6 over 9. And look at that, we can simplify it again. We can go to 2 over 3. There we go, there's our final answer. But what about addition? Addition with fractions. So if we have something like 1/2 plus 1/2, well, it might seem kind of straightforward. We're gonna get 1. But what is 1 equal in terms of a fraction? Let's put it into an improper fraction form. This is actually equal to 2/2. And we can see that we've gotten, these guys have been added together. 1 plus 1/2 is equal to 2/2. But this doesn't always work. So let's say we have 3/8 plus 4/5. Okay, what would we do for this one? Well, maybe you think we can do 3 plus 4 is 12, and 8 plus 5 is equal to 13. But that is absolutely not the answer at all. That is absolutely incorrect. But don't worry, it makes sense to make that mistake. There's little difference between these two questions. Over here, the denominator is the same, whereas down here, the denominator is different. 8 and 5 compared to 2 and 2. So, if you want to be able to add the numerators together, the denominators have to be the same. And this is a rule. It has to always be the same. But what if they're not the same? What can we do? A method to convert from denominators to another one. So let's use a bit of an easier one. Let's go with 1/2 plus, let's go with 2/3. Okay, this is a little bit simpler. How can we get these guys to be the same? Well, let's multiply them. So I'm gonna multiply 1/2, because remember, fractions are relative. So if I multiply 1/2 by 2, where I multiply both sides, and then I'll get 2/4, correct? And that's actually, it simplifies back to 1/2, but we can do that. We can go upwards as much as we want. So let's actually multiply this one not by 2 but by 3. So we're gonna get 3/6 plus 2/3. Okay. Now the denominators still aren't the same. So what can we do? We can multiply this guy by 2. So we're going to get 3/6 plus, we do the same thing for the numerator, so we're going to get 4/6 as well. Now the denominators are the same, and therefore we can just add them up. We're going to get 7/6. Okay, let's do some problems. I'm going to write in blue so we can see that my writing is a little bit different from the question. So, the first question, convert 42/100 to a percentage. Oh, they've made it easy for us. They've already put it under 100, and we know that if anything has a denominator of 100, we can just forget about it. We can just say it's 42%. There we go. So, that's pretty self-explanatory. There's our answer. Alright, the next question, convert 0.05 to a fraction. So, how can we actually do this? So remember, 0.05 is in terms of 1. So, how many times does this 0.5 have to be multiplied to become 1? Well, we can do this. 0.05 times 2 equals to 0.1. Okay, and we know that 0.1 times by what? Times by 10 equals to 1. So we know that because of these two numbers here, 0.05 times 20 equals to 1. Therefore, 0.05 is actually just 1/20. And if this was a little bit too a little bit too complicated, and if my working out doesn't really make sense, then just go back to the one that we worked with. So 0.05, actually, did we work on this one? Oh, well, maybe we didn't. Okay, I'll show you how to do it anyways. So 0.05, this is our place value, correct? This is actually 5 times 0.01. So remember, this 0.01, this is called the hundredths place value. So it's 5/100ths of 1. Okay, so how many? So this 5/100ths. It's like in the name. It's 5/100ths, right? 5/100, and we can simplify this. It's just 1/20. It's pretty simple. I mean, you can use either way. This is one method. I just do this in my head in like a second, or you could do it like this, and you convert. So it's up to you. Both work. They're both perfectly fine, and you should end up with a final answer of 1/20. Let's move on. Okay, so we got some operations. What is 1/3 times 2/3? By the way, feel free to pause the video and work on these questions by yourself before I solve them for us. And yes, I am using the letter X to represent multiplication. What is 1/3 times 2/3? Okay, let's rewrite this. 1/3 times 2/3. Well, remember with multiplication, we can just multiply them. So we get 1 times 2 is equal to 2, and 3 times 3 is equal to 9. So that's our answer. Pretty simple. And when I say just multiply them, I mean denominator multiply with denominator, numerator multiply with numerator. Okay? Do not multiply them across like that, because that would be division. Okay. What is 14/5 times 2/15? Well, let's rewrite this a little nicer. 14/5 times 2/15. Well, it's literally the exact same thing. So what is 5 times 15? That is 75. Let's put that over 75. And what is 2 times 14 is 28. Can we simplify this? Let's think. I'm thinking 7, 8, 9, no, 4, no. I don't think we can. So that's our answer. Alright, finally we got some addition and some subtraction. And I'll explain how that works in just a second. Okay, so we got 1/4 plus 3/8. So we know when we're adding fractions, we have to make the numerator the same. So we can rewrite 1/4 in terms of 8. So let's multiply 4 by 2, and if we do that, then we have to multiply the top by 2 as well. So we're going to get 2/8 plus 3/8. And once we have the same denominator, and these two are the same, we can just add the numerators. So we're going to get 5/8, which is pretty simple. That's our answer. Okay, what is 17/5 minus 13/5? So this one's a little bit different because it has a subtraction symbol. But don't be worried. Minus just means plus a negative number. This far into the course, you probably don't know what a negative number is, but that's fine. We can work with this just fine. So let's rewrite this. 17/5 minus 13/5. And this question is actually pretty nice. The denominators are the same. So we can just focus on the numerator. So we got 17 minus 13. And we know how to do 17 minus 13, which is pretty simple. It's just 4. So our answer is going to be 4/5. Thank you for watching kuroturo. This is the first video. I'm sorry that the format is a little bit all over the place. But yeah, this was numbers 1, fractions, decimals, and percentages. The next video coming up is ratios and some higher level fraction work, as well as area and perimeters. And that's going to be part of geometry 1. So look forward to that. If you like this content, then make sure to subscribe, like the video. It'll get this video out there to more people. And if you have any tips, please comment. If you have any things to say or anything like that, go ahead and just comment it for me to see. I promise I can reply to all of them. Oh. Sorry. And we actually have a website called kuroturo.com. So I don't know if it's up right now, but if you want to, you can check that out. And we've got all the content that I'm doing on these videos on the website, just in written form. So if maybe you don't have time, or you don't have earphones or something and you're in public, go ahead and read the documents instead. But yeah, thank you for watching. This has been Aaron. Hopefully you've learned something from this video. See you.